So for the subject of fluid machinery, first topic is nomenclature and definition. This is a prerequisite nito is yung fluid mechanics. So start with vapor pressure. Knowledge of vapor pressure is extremely important when selecting pumps in their mechanical seals. So vapor pressure is the pressure absolute at which a liquid at a given temperature starts to boil or flash to a gas at a given temperature. Starts to boil. Yan. Absolute pressure PSIA equals the gauge pressure PSI gauge plus atmospheric pressure. Water and water containing dissolved air will boil at different temperatures. This is because one is a liquid and the other is a solution. A solution is a liquid with dissolved air or other gases. Solutions have a higher vapor pressure than their parent liquid and boil at a lower temperature. Next is cavitation. Cavitation can create havoc with pumps and pumping system in the form of vibration and noise. Bearing failure, shock breakage, pitting on the impeller, and mechanical seal leakage are some of the problems caused by cavitation. So when a liquid boils in the suction line or suction nozzle of a pump, it is said to be flashing or cavitating, forming cavities of gas in the liquid. This occurs when the pressure acting on the liquid is below the vapor pressure of the liquid. Yan ang note niyan. The damage occur when these cavities or bubbles pass to a higher pressure region of the pump, usually just past the vent tips at the impeller eye, and then collapse or implode. So next, NPSS. So ito yung mag-limit ng cavitation. Net positive suction head is the difference between the suction pressure and the vapor pressure. And pump design and application jargon, NPSSA is the net positive head available to the pump. And NPSSR is the net positive suction head required by the pump. Okay, the NPSSA must be equal to or greater than the NPSSR for a pump to run properly. So, available sa pump mo. Okay. One way to determine the NPSSA is to measure the suction pressure at the suction nozzle. Then apply the following formula. NPSSA is equal to PB minus BP plus or minus GR plus SB, where P sub B is the barometric pressure in feet absolute. Later, malaman natin kung ano yung value niyan. GR is the gauge reading at the pump suction in feet absolute plus if the reading is above barometric minus if the reading is below the barometric. And SB is the velocity head in the suction pipe in feet absolute. And PSSR can only be determined during pump testing. To determine it, the test engineer must reduce the NPSSA to the pump at a given capacity until the pump cavitates. So makukuha mo na. At this point, in the vibration levels on the pump in system rise and it sounds like gravel is being pumped. Centrifugal pumping. Centrifugal pumping terminology can be confusing, so the following section addresses this term and how they use. Head is a term used to express pressure in both pump design and system design when analyzing static or dynamic condition. This relationship is expressed as head and feet and pressure in PSI times 2.31 divided by specific gravity and gravity of fluid. So water is 1.0. Pressure in a static system is referred to as static head and in a dynamic system as dynamic head. We're not moving, so static head. So to explain static head, let's consider three columns of any diameter. One filled with water, one with gasoline, and one with salt water, figure 1. If the columns are 100 feet tall, see the figure, and you measure the pressure at the bottom of each column, the pressure would be 43, 32.5, and 52 PSI. Yan. Kasi yung specific gravity niya, divisor. Di ba? So static head using various fluid. Yan. So this is because of different specific gravities or weights of the three liquid. So remember, we are measuring pounds per square inch at the bottom of the column, not the total weight of the liquid in the column o yung pressure niya. The following four terms are used in defining pumping system and are illustrated in figure 2. So see figure 2. So the total static head is the vertical distance between the surface of the suction source liquid and the surface liquid level of the discharge liquid. Ito. Ito yan. Ito yung suction level mo and discharge level. Sa kabilang side, pag below, ito siya. Tawag dyan, static lift. Okay, letter. Static discharge head is the distance from the center line of the suction nozzle to the surface level of the discharge liquid. Ito, tingnan nyo yung figure. Then, not moving yan. Pag may velocity, so magiging, pag tinotal mo, magiging total static, total head. Static suction head applies when the supply is above the pump. It is the vertical distance from the center line of the suction nozzle up to the liquid surface of the suction supply. This one. Suction lift, ito, applies when the supply is located below the pump. It is the vertical distance from the center line of the suction nozzle down to the surface of the suction supply liquid. Sa suction lift, andyan yung sensitive yung cavitation dyan. So velocity, friction, and pressure head are used in conjunction with the static head to define dynamic head. Velocity head is the energy in a liquid as a result of it traveling at some velocity v, so when moving. So it can be thought of as the vertical distance a liquid need to fall to gain the same velocity as the liquid, as a liquid traveling in pipe. So this relationship is expressed as h sub is equal to v squared over 2g, where v is the velocity of the liquid in feet per second and g is 32.2 feet per second. Okay, nasa English units tayo. SI, same approach. Friction head is the head needed to overcome resistance to liquid flowing in a system. This resistance came from the pipe friction, valves, and fittings. Valves in feet of liquid can be found. Values in feet of liquid can be found in hydraulic institute pipe friction manual or other source. Pressure head is the pressure in feet of liquid in a tank or vessel on the suction or discharge side of the pump. It is important to convert this pressure into feet of liquid when analyzing systems so that all units are the same. If vacuum exists and the value is known in inches of mercury, the equivalent feet of liquid can be calculated using the following formula. Vacuum in feet is inches of mercury times 1.13 over specific gravity. Ano yung vacuum in mercury? So when discussing how pump performs in service, we use terms describing dynamic head. In other words, when a pump is running, it is dynamic. So pumping systems are also dynamic when liquid is flowing through them, and they must be analyzed as such. To do this, the following four dynamic terms are used. So the total dynamic suction head is the static suction head plus the velocity head at the suction plants minus the total friction head in the suction line. Kita nyo yung ito. So plus velocity head dito. Okay, sa suction side dito. So madadagan ng velocity head plus yung minus yung friction. So total dynamic discharge head is the static discharge head plus the velocity head at the pump discharge plus the total friction head in the discharge system. So dito plus yung friction sa suction is minus. Para pag kinuha mo yung difference na is mag-a-add siya both. This can be determined in the field by taking the discharge pressure reading, converting it to head, and correcting it to pump center line, then adding the velocity head. Total dynamic suction lift is the static suction lift minus the velocity head at the suction plants plus the total friction head in the suction line. To calculate dynamic suction lift, take suction pressure at this pump suction plants, convert it to head, and correct it to pump center line, then subtract the velocity head at the point of this gauge. So gauge steadying. So the total dynamic head now is in a system is the total dynamic discharge head minus the total dynamic suction head when the suction supply is above the pump. When the suction supply is below the pump, the total dynamic head is the total dynamic discharge head plus the total dynamic suction head. Okay, kasi nai-elevate mo yung total. Okay, so centrifugal pumps are dynamic machines that impart energy to liquid. This energy is imparted by changing the velocity of liquid as it passes through the impeller. Most of this velocity energy is then converted into pressure energy, total dynamic head, as the liquid passes through the casing or diffuser. To predict the approximate total dynamic head of any centrifugal pump, we must go through two steps. First, the velocity at the outside diameter OD of the impeller is calculated using the following formula. B is equal to RPM times D over 229. Right. Where B is the velocity at the periphery of the impeller in feet per second. D is the OD of the impeller in inches. RPM, revolution per minute of the impeller, and 229 is a constant. Okay? Parang ano siya? Yung peripheral velocity. Mapay D N over 12. Ganun yun. So second, because the velocity energy at the out OD or periphery of the impeller is approximately equal to the total dynamic head developed by the pump, we continue by substituting B from above into the following equation. Where S, total dynamic head developed in feet. B, velocity at the OD of the impeller in feet per second. And G is 32.2 feet per second squared. So makuha mo ng equivalent head. And that is the total dynamic head. So kita nyo doon yung velocity at the periphery is the equivalent sa total dynamic head. Kasi yun yung force mo, ma-force yung liquid para mag-flow sa pipe. So a centrifugal operating pump operating at a given speed and imperial diameter will raise liquid of any specific gravity or weight to a given height. Therefore, we always think in terms of feet of liquid rather than pressure when analyzing centrifugal pump and their system. Okay. Wait, yan. Nagaloko lang. Wait lang. Wait lang tayo. Ang hirap na ulitin. Okay, continuity equation. The continuity equation is used to relate fluid velocity to a change in pipe's cross-sectional area. Remember the fluid mechanics. There are two versions of the continuity equation. One version is for compressible fluid, equation 1, since the density could change as the pressure changes, while the other is for an incompressible fluid, equation 2. When using this equation, there is an assumption that flow rate is constant. So the flow rate formula is rho A1 rho 1 times A sub 1 times B sub 1 is also equal to rho sub 2, A sub 2, B sub 2. So yung state points o points doon sa pipe, yung mga 1 and 2. Where rho is the density, A is the cross-sectional area, and B is the velocity. When density is incompressible, yung fluid is incompressible, density is approximately constant. So Q is equal to A1, B1 is equal to A2, B2. This is flow rate. Yung sa equation nun, that is mass flow rate. Okay? Yun. So, sa water, so this is incompressible. Approximately incompressible. Sa mga gases, so ito yung mass is constant. Next, the steady flow equation, energy equation. Gagamitin pa natin to. Kaya nga inu-emphasize yung mga definitions and nomenclatures. Pero remind lang yung mga gagamitin natin. For steady flow with one inlet and one outlet, both assume one-dimensional and letting section 1 the inlet and section 2 the outlet. Then, in low speed, nearly incompressible flow with one inlet and one outlet, we may write, so write P over gamma plus B squared over 2G plus C in is equal to P gamma plus B squared over 2G plus C out plus H friction minus H pump plus H turbine. So pump is minus kasi work done. Work run on the system. So turbine is plus kasi H turbine done by the system. So the S term are all positive. That is friction loss is always positive in real viscous flow. A pump adds increases energy, increases the left-hand side. So left-hand side andun sa in. Okay? And a turbine extract energy from the flow. If HP and or HT are included, the pump and or turbine must lie between points 1 and 2. Bernoulli's equation is a general energy equation that is used for solving fluids flow. It relates elevation head, pressure, and velocity head. Since the conditions of using Bernoulli's equation, 1 is no fluid friction, 2 fluid is incompressible, and 3 negligible changes in thermal energy. So, yan. So Bernoulli's theorem, neglecting friction, the sum of pressure head, velocity head, and elevation head of a point is equal to the sum of the pressure head, velocity head, and elevation head of another point. So P sub 1 over gamma plus P sub 1 squared over 2G plus C1 is equal to P sub 2 over gamma plus B sub 2 squared over 2G plus C2. So where pressure head is P gamma, velocity head is B squared over 2G, and elevation head is equal to C. Yan ang Bernoulli's equation. Walang work, walang heat added, or thermal energy, walang friction. So this is the end of this topic.